Sustainability in the construction industry. Our guest for today is leading a company that aims to promote eco-friendly construction through innovative materials and products. Ria Canlas is the woman behind Piety Technology Incorporated.
The woman of today was a mere dream for a woman of yesterday. History has shown how difficult it is for a woman to cement her space in the realm of science. But today, we take the lead. We set the standards. We are in the front lines. We are women. We work to create a world where a woman can choose science as her journey, where technology is her uninterrupted road, and progress is her destination. We work to create a world where a woman in science is the norm, not the exception. A world where she is a constant educator, innovator, mentor, and leader. A world that is, and will continue to be, an inclusive and diverse global scientific community.
I am Dr. Maharlika. I am an engineer scientist, and I am a woman in science.
Good afternoon, everyone. Can you hear me?
Yes, sir.
I'll
Yes, po.
just share a video to everyone. Wait. Medyo hindi lang ako sanay sa Google Meet. Wait lang. How can I share the audio in Google Meet? Do I have to share the entire screen?
Meron pong button kapag mag-share screen po sa gilid na nakalagay po, share audio rin po.
Hindi ko siya makita. Sorry Siguro itong top na to, share audio. Kinakain ako lang. Entire screen I select the entire screen, but I actually cannot see the share audio. Pakisabi na lang kung naririnig niyo yung audio. Can you hear the audio?
Yes, po.
Sustainability in the construction industry. Our guest for today is leading a company that aims to promote eco-friendly construction through innovative materials and products. Ria Canlas is the woman behind Piety Technology Incorporated.
I wanted to make an impact by solving real problems. Malasakit is not just a branding, but it's actually the way of operation of Polite. It's very important now na ngayon we have good design in the Philippines. Ako nga, hindi ko na-realize na I'm doing good design. I optimize my products so that it becomes available and affordable to socialized housing. When you use Polite blocks, you already eliminate plastering, painting. There's less processes involved in the use of my materials. Yung tibay nandoon, malasakit, safe ka na nakatira ka sa bahay mo. Ang good design also extends beyond its usability. So you're saving the future generation. Technology innovation and design innovation are both keys to economic progress. And we combine them both. There will now be no need to trade beauty with cost or cost with strength.
Okay, so I actually shared that video to propagate the value of innovation within the construction industry, where I am, of course, part of the National Innovation Council, and one of my role is to give direction in innovation. And also, but just what your professor had said a while ago, engineering management encompasses all fields of engineering, no? And in my case, in the 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 call of estimation and controlling cost also encompass both manufacturing and construction in my discussion, because I'm also into manufacturing. So my I will be discussing about estimating and controlling costs. Now let us have the cost and design economics, wherein there should be a balance between the technical feasibility and economic feasibility. So when we say technical feasibility, of course, we know that this is something that will give us our technical requirements in terms of perhaps strength, stability of the intended structure that we want to build. But at the same time, it has to be economic. When we say economic, it means it is not cheaper, but in terms of cost, it is cost efficient. So these two, when combined together, needs particular techniques, no, for us to balance this. Now, I would like to focus on terminologies that are being used when it comes to controlling costs. And I'd like you to understand the word costs. Okay? Um, Cost is always an outflow in our cash flow diagram. If you have your engineering economy and we draw the cash flow diagram, and there are only two ways how cash flows within a particular project, it is going up as an inflow, it's called revenue. And if it's going down, it's called expenses or expenditures or cost, in other words. Cost always goes out of our cash flow diagram. And we have to understand the implications of cost depends on the following. So in a particular construction project, there are costs that varies in terms of frequency of occurrence. There are costs that only spend once, or spend on a very regular basis. Could be monthly or annually, etc. We also have to understand a relative magnitude of that cost. When we look at the Procurement Act of the Philippines, you could see there are instances when we need to determine the percentage of its job or of its scope of work for us to know if we need, if we are allowed to have variation cost, no? um, we have to get the effect of that cost in the overall costing of the whole project, because we need to have more focus on those costs that has bigger percentage on your project. Specifically, those percent costs that are about 15% and above of your cost. Why? Because of course, the cost that has the scope of work that has the bigger magnitude will mean this is where you're gonna get most of your collection when you are, of course, in the project. And of course, the degree of impact on the study may also mean very related to relative magnitude. There are certain, as I've said, there are certain percentage that allows you to do variation orders, etc. Now, first of all, I would like to for you to know these different types of costs called fixed cost, variable cost, incremental cost. These types of costs are most probably used in manufacturing setup. Okay, example, you are producing several numbers or units of products. Okay, when you say fixed cost is defined as unaffected by the changes in the activity level, or these costs are known to be constant, irregardless of your activity. When we say activity level, in the case of manufacturing, we call it uh, me, in my case, I call it low level, mid level, high level. Depends on the number of quantity that I produce. Example, if I say low level, I mean I can produce 1,000 hollow blocks per day. If I say high level, I will be producing 10,000 pieces of hollow blocks per day. So regardless of how many I produce, this cost will still be there. It will still be present. Okay? So maybe some of you will now be trying to think of fixed costs, no? So what are examples of fixed costs? So examples of fixed costs, meaning you're gonna spend this even if you produce zero or you produce maximum. So example of these are the rental of space. Um, if you have salaries for your administration, the administrative, no? Those that manages the office and not directly akin to the project. Okay. So what else? I also consider in my fixed cost the cost of certain types of utilities that are incurred in my office. And also if I have research costs, etc. Okay. By the way, because I'm a research-based uh, company, so in other words, I really allot a percentage or I allot a certain amount for research. Next, so tatandaan nyo lang fixed cost, it's always constant. Gumawa ka or hindi, you have to pay that cost. Variable cost, of course, by the root word vary, it means it changes. It changes relatively linearly to the quantity of output or to your level of activity. Meaning if we produce zero, then there's zero variable cost. If we produce maximum, we have maximum variable cost. So what are example of variable cost? So variable costs are as follows. Your material cost. Okay? Of course, the material cost is depends on the number of the product that you have produced, the labor cost as well, and the equipment cost. So these and some other, I put also utilities under variable cost. Utilities used to produce per output of product. So that's variable cost. It changes. Depends on your level of production. Another word is incremental cost or the incremental revenue. This is an additional cost result from increasing your output by 1 unit. Example, what happened if I produce 1,000 hollow blocks per day? And what happened if I produce 1,001 hollow blocks per day? What effect does it mean to me or to the company as soon as I change my level of production? So to further understand this cost, let me discuss to you this example. In the table, you could see the cost of producing a particular product, and we are asked to give the unit cost per level of activity. Um, so in this particular example, we could see I vary the quantity of production. Example, I am producing hypothetically, let's say this is a hollow blocks, okay? So let's say I produce at one batch of operation, I produce 5,000 units of hollow blocks, or I could produce 10,000 hollow blocks in one batch, or I can produce 20,000. So I would just have to put in my table my cost so that I would know how much is the total cost of the hollow blocks per unit. Okay? So let us say my fixed cost is 100,000. So this is my rental fee, etc. Okay? So this is 100,000, 100,000, 100,000, regardless of level of production. And then let's say the variable costs, the labor, materials, and equipment of producing 1 unit of hollow blocks is 30 pesos. So there I will multiply 30 times 5,000 is 150,000, 30 times 10,000 is 300,000, 30 pesos times 20,000 is equal to 600,000. Total cost is equal to fixed cost plus variable cost. So you just have to add 100 plus 150,000 is 250, 100 plus 300,000 is 400, 100 plus 600,000 is 700. How do I get the unit cost? The unit cost is the total cost divided by the quantity. So 250,000 divided by 5,000 is 50, 400,000 divided by 10,000 is 40, and 700,000 divided by 20,000 is 35. This is 50 pesos per unit, 40 pesos, and 35,000 per unit. So what does this mean? Okay, so this means that the cost of producing my product greatly is affected by my variable cost and fixed costs. In other words, I am producing the same quality of products, but you can see the unit cost change because of my level of activity. This is called maximization and minimization, or this is called maximizing the use of your fixed costs simply uh, by maximizing the number of products that you produce in one batch. This is a strategy for manufacturers to have more increment income. For example, I will sell my hollow blocks into 60 pesos. So if I will just have a low level of production, I will just have 10 pesos increment income. But if I produce 20,000, then I will have how much? More than 10 pesos. I will have 25 pesos of the increment income. So it's a strategy of manufacturing so that you would be able to maximize your increment income. Okay? Now, let's move on to other names of cost. Direct cost, indirect cost, and standard cost. These costs are approximately the same as the concept of fixed and variable cost, but this nomenclature is more applicable on construction than production. Okay, so what does this words means? Of course, I know that you have your project management subject, and probably you know about this already. Okay, direct cost is measured to specific output or work activity. So this is directly proportionate, linearly related to your output. In other words, direct cost is very much similar to your variable costs. So the zero output means zero direct cost. Maximum output means maximum direct cost. Indirect cost is difficult to attribute to a specific output or work activity. Why? Because it is not akin to the activity. Example, construction. Anything that is not related to the construction itself is called indirect cost. So in some other ways, indirect costs may also be similar to a fixed cost. Okay? Because these costs were incurred not directly attributable to the output. So example of these are the overhead or the burden cost. Okay, we'll be discussing more in detail later. While a standard cost is called the representative cost per unit or output. So this is called maybe unit cost. Okay? There are many reasons why we need a standard cost or a so-called unit cost. Okay? What are the uses of standard cost or unit costs? Well, when I say unit cost, it means this is the cost per the unit of measurement that you use for a particular scope of work. Example, some will be measured in terms of volume. Example, cubic meter. Some will be in area. Example, square meters. Some in length or linear meter, etc. It depends on the type of measure that is standardly applied to a particular scope of work. So the standard cost is very important because it is being used to estimate future manufacturing costs or even future construction costs. Um, uh, the definitive or the detailed estimate is normally being done on the first time, and then as you move on to your next projects, you don't need to do the same detailed estimate because you already arrive at your standard cost. So in other words, it's very easy for you to estimate a future project because you already have a record of your standard cost. It is also used in measuring operating performance by comparing actual cost versus the standard cost. So you would know if you overspent or underspent in your project simply by comparing it on your standard cost. This is also very usable in preparing your bid documents or bid or quotations to your customers. And it is used to establish the value of work in process and finished inventories. Yeah, it is very easy to do inventories of the remaining work or done work based on standard cost. Well, we have standard costs. Typically, DPWH issued standard cost, and NHA uses the standard cost of DPWH in their projects. Of course, this is applicable for government projects. But in private companies, they all have their standard costs. The standard cost will only change depends on the movement of the economy. Example, there's inflation. There's a change in the material costs. There's a change in the manpower or labor rate, okay, or salaries, wages. So whenever there's an inflation going on and it is affecting very much your standard cost, then that's the time that we adjust your standard cost. Nonetheless, of course, standard cost will also affect some variables like example, different geographic locations. Okay, there's a so-called life cycle cost. This is the summation of all the costs related to a product, a system, a service that includes construction during its span of life. And this is just to understand that in every project or production, there's always a so-called acquisition cost and operation phase. Of course, acquisition means the time when you need to do your assessment and to define your requirements. It is also the time when you do your conceptual or preliminary designs or prototyping and testing. And this is also the time when you do your detailed design, your production or construction planning, facility and resource acquisition. So we got to be ready first. That's why we have the so-called procurement. Okay? Nakikita natin yan. We saw the word procurement in our costing because there's really a cost to procure. And in some other times, procurement may affect the cost of your project. I'll be discussing later. Okay. And of course, once you're already done with the acquisition, then there's this operation phase wherein you do your production or construction. And after that, there's a so-called maintenance and support, then the retirement and disposal, or we call it the life of for the end of the economic life of any project. Okay. Now let us have this cost-driven design optimization. In a life cycle, we always consider number first, what is your initial investment cost? So how much this project costs? Okay, that's just what it is. Next, how much does it cost to operate and to maintain your project? And what are your annual expenses or dues that you need to pay whenever this project is already usable? And the fourth one, which is very important nowadays, when we have when there's climate change and when there's all this green gas houses issues and the UN SDG 2030 that we need to embrace and be actively participating in how we're going to mitigate climate change, there is of course a design for environment or the green engineering. Kaya nga there's this so-called LEED where there are some projects that are undergoing accreditation for LEED, right? That it it is acceptable with the green engineering standards. All right, I'll not discuss this part. So let's go to methods of use in cost estimation. So cost is always an expense, it's always a cash outflow. As I've said a while ago, estimate is an assumption. Therefore, it is not 100% true because it's an assumption. I haven't seen a project that is 100% true, because estimate is a forecast of any future events. It's like we are like we are like fortune tellers, where we would like to assume what will happen in the future. Therefore, the best estimator is the one that has the least percent of error from what was actually spent in a particular project. Now, to have a very accurate cost estimation, or a forecast of the future, there are different types of approaches. The number one approach or component one is called the work breakdown structure, or WBS. This is defining at successive levels of detail the work elements of a project and their interrelationship. All you have to do is to break a bigger project in smaller projects or smaller parts. Okay, a big task example, um, construction of a building. It's a big task. Then let's broke it down into small tasks, and this is called WBS. So WBS, you may want to start with drawing the various levels of WBS. The one that you had the screen is called the three-level WBS. The first level normally is the project. Then you split it up as a second layer, and then split it further as a layer. This is a three-level WBS. It can be 4 level, it can be 5 level, depends on the type of estimation you are doing. Okay? So example, if I mean construction of a house, then in my case, I will have my second layer as architectural works, civil structural works, mechanical works, electrical works. This is how I'm going to break it down. Well, there is no wrong answer for this. It depends on the strategy of the estimator, how the estimator wants to break down the work. Okay? So, hypothetically, I will subdivide my work into my electrical works into roughing in finishings, mechanical seam, roughing in finishing, and these are just hypothetical. So, of course, there are so many works under civil works and architectural works, but just to give you an example of, just to give you the concept of breaking it down. Okay, it does not matter how many branches there are, two branches, three, four, indefinite number of branches, as long as you can divide it into sub work or sub task. Okay, that's WBS. There is no software that, or any tool that will give you instantly what are the scope of work involved in one particular job. Then the only way that you can do your WBS is to undress the project. When we say undress, hubaran mo, no? Undress it. Hubaran mo yung project. Okay? So if it's a house, uh, then start by removing the roof. And what do you see after removing the roof? You saw the roof framing. What else do you see? You saw the roof beams. What else do you see? You saw the walls, until you saw the foundation or the footing. You just undress it and put it in your WBS. This is a checklist as well, can act as checklist, so that you are pretty much sure that you don't left or leave out an important task. The second integrated approach is the cost and revenue classification. Okay, so this is just a matter of delineation or identifying which is the cost and which is the revenue, so that you know how it affects your cash flow. Okay, for instance, you have these long words, no, you know, cost engineering is like accounting, no, because they are meant the same. They're working on values or on money. So, parang pareho sila ng lingwahe. They are just the same, they use the same language, but it's just a matter of knowing accounts. Accounting works by letting you be reminded of what that account is. What is the account type, no? So we have capital investment, labor cost, material cost, maintenance cost, property tax, insurance, there's scrap cost, your overhead cost, disposal cost, revenues, market salvage values. So if you have all these costs and you would say, alin ba dito yung outflow, cash inflow, so what goes in, what goes out, no? So that you know. Well, in this particular example, malinaw naman, may mga word na nagbibigay sa atin ng cue that it's a cost, no? It's a outflow, it's an expense. Kasi may nakalagay na cost or may nakalagay na investment. Revenue, of course, is going in or cash inflow, and of course, salvage values are also cash inflows. Okay? The number three component is your estimating techniques or your estimating models. You have to select what are the different mathematical models that you wanted to use in your estimation. So there are, of course, varied strategies to do your cost estimations. Okay, I'll just leave this. Okay, so let's have the classification of cost and revenue estimates according to the detail, accuracy, and purpose. How detailed you want to be, it depends. Okay, first, if it's just an order of magnitude estimate, example, you just need an initial evaluation. You just need this value to give your boss a rough estimation or to give your client a rough estimation of your project. Then the accuracy of this is only plus or minus 30 to 50%. So when you do order of magnitude, you are only applied to one or two levels of your WBS. A while ago, I showed you three level of WBS, but if you just using one or two levels, then you are just giving your customer, your boss, a 50 this kind of accuracy, almost 50%. So pag sinabi mo, oh, how much do you think this project costs? When you say, oh, this project costs 100 million. So what's the reality? The reality is it may cost 50 million only or 150 million. Okay. Now you can do semi-detailed cost or the budget or estimate cost. If you really wanted now to adapt or to give a budget for a particular project, no, but not necessarily yet, but not yet in the process of constructing the project. Okay, this is used in conceptual design, and the accuracy is plus or minus 15, and your level of WBS is up to 2 or 3 levels. So, example, if your cost estimate is 100 million, maybe the true value or the actual value may be 85 million or 115 million. And of course, the more rigorous of all is the definitive or detailed estimate, which is, of course, it's already used for bidding and construction stage. And the accuracy is plus or minus 5%. And you may apply this to level 3 and successive levels of WBS. I suggest to use 4 levels. Yeah, but 3 is okay na rin. But if you can do 4 levels of WBS, then it's good. So what does it mean? It means that if you really do your work properly, if your detailed estimate is 100 million, then the actual value may mean it's 95 million or 105 million. Okay? Now, what are the selected estimating techniques or models? We can use indices or ratio technique. Indices and ratio technique means estimation of any present, future cost and price estimates. Example, if you have a standard cost and there's inflation, okay, so what we're gonna do is to use indices or ratio technique. Index and ratio technique formula are found in the Procurement Act of the Philippines. You don't have to guess that because it's already written, the particular formula of projecting present and future costs based on the ongoing inflation rate or movement in the market value. Okay, so this is where indices are being used. Unit technique is also being used, meaning na unit technique, you have a unit cost and then you just multiply it, then you already know your cost. Factor technique means you identify a particular factor. Example, you open your estimate book, di ba, yung Pahardo, pag binuksan niyo, puro factor technique. No? Pahardo is using a lot of factors. Example, if you wanted to get the quantity of cement, of sand, of gravel, just have to use the factor. Multipliers. It's called multipliers. So that's factor technique. And of course, there's the so-called parametric cost estimation. Parametric cost estimation is that various methodologies or techniques also. Example, the CER or the cost estimation techniques. Tolarba, the book of Tolarba, the red one is Tolarba is more on CER or cost estimating relationships. Example, in his book, you'll see relationship of how do you estimate the volume of the kilograms of steel when you have this volume of concrete. How do you estimate for the number or kilos of nails for a particular board feet of wood of lumber? Okay, so that's cost estimation relationship. Okay, the use of historical data such as cost drivers is also being used. Historical data for me is like more of plotting. Example, you have to plot values that you have in past, example, past 10 projects, and then get those costs, okay, and to see how it's changed in time, and then make the the adjustment on the cost based on historical figures. Of course, we can use statistical techniques such as multiple regression, which I published a paper where I use regression in terms of estimating a building. And I would not be discussing this because I use a separately different type of technique in estimating. Okay. Um, and then, of course, certain mathematical techniques only if you would know a particular relationship of these parameters, example, linear, power, logarithmic, etc. Cost estimation in the design process can be done by bottom up or top down. Okay. Typically, when it comes to construction projects, it's always bottom up. It's called design to price, or what does the product cost, which is American style. Okay, so what you do, you first estimate, and then after you do estimating, you will now say tell to your client, oh, this is the value of your building. Okay, top down is different. This is more of a Japanese approach, and top down is targeting a cost, or what should the product cost. For instance, Japanese will say, or they say, oh, I want affordable tiny houses for everyone, and so I want you to offer a house that only costs 500,000 and sell it to the people. Okay, so if you target 500,000, then you have to adjust your design. Okay, you remember, no, you don't let the quality or the standard of the project suffer because of the so-called top-down estimation. Rather, you adjust your design, okay, so that you could still have that same value or quality of the product of the project, even if you have a targeted cost. Maybe targeted cost or top-down estimation is better for mass production or mass housing if you're doing it many times. No, you're repetitive. Pare-pareho yung ginagawa mo. 3,000 houses, very much repetitive, then target costing is applicable. Now, I'd like to teach you detailed estimating. Okay, so in detailed estimating, we first project the direct cost, always the direct costs. And there are three types of indirect costs, but I added one, the subcontract cost. Okay, let's start with the material cost. Your direct cost will always be starting from quantity. So where do you get your quantity? You go on your plans and specifications and do direct counting or direct measurement on your plans. Okay? Sabi ko nga sa mga estudyante ko before, it's now the time to use your Toblerone, yung ano na yung triangle na metric. I call this the metric rule. Okay? Kasi nagko-convert ka na, di ba yung mga plano natin, merong mga 1:100, 1:20. This is the time to directly measure the quantity from the plans or the specifications. Plans and specifications, by the way, are coupled. They always go together. And whatever you cannot find in the plans are found in the specifications. The specification supports the plans, no? Because the plans will look very messy if everything is put in the plans. Primarily, the purpose of the specification is to write the type of material to be used and the methodology of construction, which definitely we cannot see on the plans. They are supporting each other. Okay, plans are more visual, specifications are more textual. Okay, so use this to get the quantity, and that quantity now will be used in all your estimation. Okay, quantity multiplied by the material price per quantity. Of course, if your quantity is area square meters, and multiply that with the material price per square meter. So magka-cancel na yung square meter, so you have now your cost, material cost. Where do you get the material price? Of course, get it from the hardware. At least get three suppliers and get the average of them. That's already your material price. For the labor cost, you also use the same quantity that you use in the material estimation. This time, use a labor productivity rate. Please, please shy away or avoid using percentage in the percentage of material cost in determining the labor cost. That method where we just simply get the percentage of the material cost, and by determining the labor cost, example, you will multiply the material cost by 30% or 35% to get the labor cost. We call it foreman approach, the foreman approach, and we discourage the use of that. Okay, you use labor productivity rates. Where do you get your labor productivity rate? First, you can get it your own. If you're a project engineer, a field engineer, it's the time to get your own, no, by observing your workers. Example, masonry works or CHB laying, and you wanted to know the labor productivity of CHB laying. So what you're gonna do, you observe your people doing CHB laying in an hour or in 8 hours or 1 day, and for 5 days, and get the average. Then you now have your own labor productivity rate. You can have it your own, or you can get a copy from big construction companies. Well, good luck if you will be able to have access to it. Maybe you can ask your friends, can you give me the labor productivity rate used by, for example, Ayala, by Megawatt, etc. Or you can use books, but be careful about the author of the book. Because if you're using labor productivity rates coming from a book, be sure that it is Filipino author. Because labor productivity is highly affected by so many things. Okay, example, the physique of the person. No, I mean, people from the U.S. may mean different from the Filipinos in terms of labor productivity. Okay, they're much taller than us, and then also the effect of humidity, climate when doing the work, etc. Okay, that's why most of the labor productivity rate that we could see from top construction companies, they have also the low, average, and high level, because there is no certainty in the labor output of any laborer. No, there are always so many factors that affects it. So all you have to do is get your historical values from your past projects, table it, and get the values of low level, average level, and high level. Productivity rate is measured in a man hour of a particular quantity of work. Example, when I say masonry, CHB laying is 4 man hours per square meter. So I measure the man hour per unit of work. But the man hours is just the same as a regular hour in our clock or in our watches. No? But the reason why we use man hours, because we already integrate the output of the labor in the hour. That is why it's called man hour. Okay? So how much can a laborer or can a construction worker do a job in an hour? So that's man hours. Okay? Then so again, we multiply the quantity with the labor productivity rate, and you can find it. You have to determine ways how you can sources out, multiplied by the labor rate. And the labor rate, of course, is the existing standard labor salaries and wages that we have in the Philippines. Okay? The machine cost is just the same as how we measure labor cost, no? Using the same quantity multiplied by the machine productivity rate. Where do you get the machine productivity rates? Get it from the supplier, because the supplier typically knows the productivity of the machine. Now, example, the Xerox machine, when the supplier says that, oh, this Xerox machine can Xerox 1,000 pages in its whole life, then you know the quantity of the productivity already. Okay, all types of machine has their productivity or life. Okay, so put it here, and then multiplied by the machine rental rate. You get the machine rental rate from ASL rates or from the known machine rental companies. If you're gonna ask me, do we charge a machine rental rate even if the company owns the machine? Yes, of course, you need to. Because this is the way for you to recoup back your investment on the machine. Some other estimators would like to add machine cost by simply identifying the number of man hours or machine hours that you will use the machine and get the cost of the machine per hour. Halimbawa, I bought a crane worth 5 million, and then I will estimate how many hours I will make use of that that crane based on my supplier. So I'll just divide 5 million by the number of hours I produce, and then determine the number of hours that I will charge in this particular estimation, na ilalagay ko machinery. You need to charge, even if you own or you do not own the machine. And the last one is the subcontract cost. Of course, you know, subcontractor. No? Subcontract is when you get a third party to do the job instead of you doing the job. Then this is where you're gonna put it. It's a direct cost for you because you're gonna pay your subcontractor. So when are the times when you need subcontractors? You need subcontractors on specialized work. Rather than you learning or relearning or having a hard time learning a special type of special work, then just hire people who are good at it to give you less pain or less stress. Add all of them is the total direct cost. Now we now get your indirect cost. The indirect cost is the hardest, and this might be the cost that will affect your bid cost. No, ito yung magpapanalo sa iyo sa bidding, and thus it needs sort of expertise already when it comes to indirect cost. No, you might want to consult older engineers when it comes to putting indirect cost, but I'll give you a scientific basis for determining your indirect cost. Number one, your overhead or the burden cost. No? Your overhead consists of all the things that are not found in the direct cost. And if you are good enough to identify them one by one, then do so. Okay? Then do so. No? So example, pasweldo sa engineers. Dyan, kasi walang engineer kanina, labor cost yun, no? Di ba? Pasweldo sa engineer, yung renta ng ng opisina mo, kung nangungutang ka, the interest of your loans, etc., etc. Ang dami ng overhead cost na yun, alright? So, again, it also includes fringe benefits, no? 13th month, the SSS benefit of your workers, all of those things are included in the overhead. Mobilization may be part of the overhead. Demobilization, mobilization are part, and a lot more things. Okay, so get a percentage of that, and that's already of the direct cost. What is the most applicable percentage if you cannot enumerate it one by one? Okay, much better if you can enumerate one by one. But if it's very hard for you to enumerate, get a percentage, and this percent is about 8 to 10%. Okay? 8. Okay na yon. Okay? Next. By the way, okay, let's go. Capital cost is the cost of money because you are going to use your money for the project instead of keeping it in a bank. So dapat, pag ginamit yung pera, may cost of money. I'll discuss that in a graph later, doon sa break-even graph, na doon ginagamit yung break-even. Doon sa period of time na namuhunan ka for your project, it is but logical to put a capital cost. Okay? Now, what is the percent of the capital cost? The safest percent for a capital cost is the bank interest rate. Why? Because sa bank kasi siya nakatago kung hindi mo siya ginamit sa project. Eh dahil ginamit mo, nagkaroon ng risk. Okay? Natutulog yung pera mo sa bangko, nangontrata ka, ginamit mo yung project mo doon, so nagkaroon ng risk. So dapat may cost of money. So it's bank rate. So how much bank rate? The annual interest rate of the bank. Depends sa capital na ginamit mo. If a small amount, then use the annual interest rate. If malaki yung amount, they use the annual time deposit rate. Okay? Depende sa laki ng amount na ginamit mo sa project. Contingency. Contingency is used to give cost to everything that you do not know and you failed to remember during the planning stage. Of course, you're not perfect to know everything. So therefore, you need to put contingency. And in fact, the Procurement Act of the Philippines allows us to put contingency because we're not 100% certain of things. No, there are called uncertainties, and these uncertainties has to be taken care of by the contingencies. So how much is the percentage used for contingency? The safe range for this is 3 to 5%. Okay, 3 to 5%. So, whenever you are asking for inflation rate, kasi pwede yun sa mga projects, for example, biglang nag-quote ka na, and then suddenly there's inflation and your project is very much affected by very high cost of materials, etc. You can get a so-called claim for adjustment of the cost, only provided that you can prove to your client that the contingency percentage of your charge is less than the inflation rate at the time. Okay? So pag nagkaroon ng inflation na 5% and you already put 5% in your estimate, then hindi ka na allowed mag-ask for a recomputation of your costing kasi naglagay ka na ng 5% contingency. But the inflation rate goes up by 5%, then pwede ka pang manghingi ng adjustment. Okay? And of course, the tax. All in all, you add this is the total indirect cost. And the profit is a percentage of the direct cost, indirect cost. And this profit, this is na-depende sa guts or sa tibay ng loob ng engineer, ng head, no? Kung ano ilalagay niyang percentage dito. Percent profit is inversely proportionate with the project costs. If the project cost is big, the profit is less. Okay, so what is the range of the profit? Well, I saw a project that charges only 8%, and this 8% profit percentage applies to a so-called cost plus project. Okay, cost plus project means the owner will pay you based on the expenses. Kaya cost plus. Kung ano yung naging expenses mo, a percent of that goes to you. There are a lot of projects where mo pag cost plus, no? So, I've had the cost plus project. So, this cost plus, bababa percent yan, 8%. To government project ranges from 8 to 10%. And sometimes up to high as 30% if your project is just a small one, okay? 30% may do. For projects like highly intensive on programming. Like example, in my case, I install load moment indicators or yung mga LMI tinatawag, yung mga nilalagay ko sa crane para pag yung crane hindi na siya nanghuhula ng ililit niya. So I can as high as 50% kasi masyadong madugo pagdating sa programming. Okay? So kaya nga depende. This all depends. Okay? So safe ka in between 8% to 30%. And then add them all is your total project cost. Okay, so before, I think this is the last slide, just to explain the break-even analysis. No, so you have here on the horizontal the unit of production, and then on the vertical your cost. So kapag kahit gumawa ka o hindi, meron ka dito tinatawag na cost na ayan yung straight line corresponds to your total indirect cost. Okay? Or total fixed cost, pareho lang. Okay? Kapag ka naman ikaw ay gumagawa, meron ka ng tinatawag na variable cost or direct cost. No? Pag zero ginawa mo, dito yung, I hope you can see my cursor. So, linear siya, direct line na ganun, naka-slope. No? Zero expense, zero yung variable cost, maximum din. So yung trapezoid na yon is your expense curve. Tapos babayaran ka ng kliyente. Pag zero na gawa mo, hindi ka pa niya babayaran. Pag maximum, babayaran ka na ng maximum. So income curve. The point of intersection of the income and expense curve is called the break-even point, which means before this point, ito, namumuhunan ka. Beyond that point, hindi na, nababayaran ka na. No? So in other words, at this point, namumuhunan ka. So ito, nangangailangan to ng cost of money that you will charge in your estimation. Okay? So that ends my presentation. Thank you.
Thank you.